Yeah, good afternoon to all of you.
Good afternoon.
So now we are going in second year, fourth semester. So topic is sedimentary and metamorphic petrology, right? So I am Dr. Sandar is the assistant professor at Dr. B.R. Ambedkar Open University, Hyderabad, right? So now we are going to first of all, what is sediments and sedimentary rocks, right? So sedimentary rocks, first of all, sediments. You see here. So sediments means okay. So sediments are loose material such as wait, rock fragments, mineral grains, and bits of shell that have been moved by wind, water, ice, or gravity. So some of the sediments come from already existing rocks that are weathered and eroded rocks, right? So now sediments are the precursors of sedimentary rocks, right? So most of the earth's surface that is covered with totally these sediments, okay? So and layers of loose material, right? Loose materials such as sand, silt and clay that is covered with sediments and layers of loose materials. What is that? Sand, silt and clay, right? So that had originated from the weathering of continental crust and either as solid debris from rocks or as dissolved substances, right? So the word this sediment, right? This sediment is derived from Latin word, remember, okay? Latin word that is sedimentum, Sedimentum. So sedimentum, which means to settle, right? To settle. A reference to solid material settling out of a fluid. Fluid means water or in air, right? So the sediments are loose solid particles originating from the breaking apart of older pre-existing rocks by the process of which one? Weathering and erosion. This one, okay? Weathering and erosion. So they form a surface, right? Surface veneer or cover on bedrock ranging in thickness from practically non-existent, right? Non-existent. That is in places where bedrock crops out at the earth surface, right? So that non-existent to few kilometers. So that sediment transforms into soil, which we know is essential for our life, right? So now, sedimentary rock. Sedimentary rocks means it forms when sediments, right? These sediments are pressed and cemented together or when chemicals precipitate from solutions, right? So now, so what is the importance of studying about this sedimentary rock? So that is the study of sedimentary rock that is enormously important because and interesting and it has great practical value, right? So the study and analysis of the structure and also textures and composition of the sediments and sedimentary rocks enables sedimentologists, right? Sedimentologists to comprehend about the origin of the sedimentary rocks in order to deduce the environment of deposition. It means like ancient shorelines, mountains and riverine, floodplains, deserts and also swamps in other regions. So now some of the example of the top of Mount Everest. All of you know about this Everest, Mount Everest. So which consists of fossiliferous limestone, right? So we know that such limestones are formed in sea or ocean, right? So it can be inferred that Mount Everest was part of an ocean floor in the geological past, right? So now we get most valuable sources of energy like what are that sources of energy means like oil, gas and coal, right? So these are the from these rocks, right? Came from these sedimentary rocks. So the fossil fuels means fossil fuels, oil and gas are derived from the which one maturation of organic matter present in this sediments and these then migrate to the suitable reservoir which is mostly porous sedimentary rocks. So the sedimentary rocks supply much of the world's iron, right? Iron means Fe and aluminum and potash and also salt and building materials and many other essential raw materials, right? So there are many reasons for studying these sedimentary rocks apart from the wealth of economic minerals and materials contained within them, right? So some of the geologists are interested in this sedimentary processes because they provide vital clues to understanding the paleoclimate, right? So much of our knowledge of the evolution of life on Earth that is derived from fossils, right? Fossils means it is coming in your sixth semester, right? That is paleontology. So that fossils preserved in sedimentary process of deposition and paleogeography and paleoclimatology, so which would contribute towards knowledge and understanding of the Earth's geological history also. Right? Now, okay, types of sedimentary rocks. Next, we are going to types, right? Types of sedimentary rocks. So, the types of sedimentary rocks, they are classified into two types, right? So, first one, clastic, right? Clastic. And second one is non-clastic, okay? Non-clastic. So, clastic and non-clastic. So, the sedimentary rocks have been variously classified on the basis of their mineralogical composition and also mode of formation and environment of deposition and also textural features, right? So that is depending on the origin and nature of the sedimentary particles and sedimentary rocks. So that's why sedimentary rocks can be divided into two classes, clastic rocks and non-clastics, right? So first we are going to clastic rocks. So what are the clastic rocks? So the sediments of clastic rocks are derived from disintegration of pre-existing rocks, right? So their grain size is quite variable, ranging from, see here, right? So that grain size is different, quite variable, ranging from clay, silt, and sand up to these pebbles, right? You see here. So here also and cobbles and boulder size materials like this, right? So these sediments are clashed, are transported by which one? Gravity, right? Gravity and running, right? Are you running water and also wind and glaciers. So these are laid down in various depositional basin and marine, fluvial, aeolian, and also lacustrine, etc., etc., under prevalent conditions of temperature and pressure, right? So this type of sedimentary deposition is referred to as clastic sedimentation, right? Clastic, okay? Clastic sedimentation. So example, some of the examples, rocks formed by the deposition of clastic materials, right? So those are conglomerate, right? Conglomerate, sandstone and shale. I will, you see here some of the pictures. Wait. Right, you see here. So this is the conglomerate, okay? And the part is sandstone, okay? Arcos sandstone. So now we're going to, and composition and texture of clastic rocks. So now in that, first one is composition. What is the composition of clastic rocks? That clastic rocks contain grains of quartz, feldspar, and mica, clay minerals, and iron oxides, and fragments of rocks, right? And lithic fragments may include pieces of limestone, mud rock, plutonic or volcanic rocks, and also chalk, etc. Some of the plant debris shells and also skeletal materials. So they also may be present in that, right? And calcite, this is very important. Calcite and amorphous silica, it may occur as secondary cementing minerals, right? So a very small amount of heavy minerals like zircon, right? ZIRCON, zircon and tourmaline, tourmalin, tourmaline and rutile, rutile, etc. So they may as well be present in that. So among the all the minerals constituents, quartz is the most abundant mineral due to, what is that? Due to its resistance to weathering, both physical and chemical, right? So, and feldspar. Feldspars are common minerals present in this clastic rocks, right? So, they are chemically reactive and altered to clay minerals during chemical weathering, right? So, I will tell about this weathering, types of weatherings, okay? And other minerals derived from the source rock, such as olivine, amphiboles, and pyroxenes, mica, and carbonates. So those are chemically reactive and tend to be absent mature clastic sediments, right? One second. Sir, చెప్పండి. లేదు నేను ఆన్లైన్ క్లాస్లో ఉన్నా సార్, నేను మళ్ళీ చేస్తాను. ఓకే సార్. So now this is the composition and texture. What is the texture? Texture, Texture. So in clastic sedimentary rocks, it exhibit clastic texture. So that is a framework consisting of variable size of mineral grains cemented by chemical precipitates or matrix. So this texture refers to grain size, right? Grain size and grain shape also. Uh, like this, right? So grain size and grain shape and sorting of sediments, which has been um, that this textures of plastic is very significant in the some that is the interpretation, right? Interpretation of geological history of the rock, right? So this is the composition and texture of the clastic rocks. And now we are going to non-clastic, right? Non-clastic rocks. So these non-clastic sedimentary rocks are made up of fragments of interlocking minerals. Locking minerals. So that is formed by chemical process such as evaporation, precipitation, and crystallization or biochemical process. So that is accumulation of remains of hard parts of organisms, right? So that non-clastic sedimentary rocks are further subdivided into two types. First one is chemical, right? Chemical sedimentary rocks. And second one is biochemical or organic. Biochemical or organic. I think. Chemical or biochemical, you see here. Okay? Okay, right. So now the chemical sedimentary rocks. So the dissolved minerals products that are removed, right? Removed from the site of weathering are transported in solution and deposited in a basin by chemical precipitation, right? Chemical precipitation. So the chemically precipitated such rocks are known as chemical sedimentary rocks, right? Chemical sedimentary rocks. So for example, limestone, right? Limestone and dolomite in dolomite. So these are the chemical sedimentary rocks. And other chemical precipitates may include ironstone and phosphates. And some rocks are produced by chemical precipitation and evaporation of substances dissolved in seawater, right? Seawater in enclosed basins. So common examples are these evaporites like gypsum, right? Gypsum, Gypsum, gypsum and rock salt, right? Rock salt, gypsum and rock salt. So this gypsum is CaSO4 to H2O and rock salt is NaCl, sodium chloride, right? So this type of sedimentation is referred to as chemical sedimentation, right? Now, biochemical. Second one is biochemical or organic. Biochemical or organic sedimentary rocks. Okay. So these are the carbonaceous materials, right? Which means like plant, right? Plant and skeletal remains, right? Skeletal remains of organisms from the major components of organic and biogenic sedimentary rocks. So some of the examples of these rocks formed by the accumulation of plant debris in swamp, right? Swamp, SWAMP, swamp are bogs. So these are coal deposits, right? So another examples, that is rocks deposited by the accumulation of micro and microorganisms, that is coquina, some of the rock are chalk deposits, right? Chalk deposits, where it is. This one. This is the limestone and this is the chalk. So this is the biochemical or organic sedimentary rocks, right? So now this is very, very important. That is sedimentary process. Okay. So in your examination, they are asking this question. Remember. Okay. So anyone are weathering, erosion, or transportation, deposition. So now the rocks existing on the earth at any given point, right? So any given point of time are exposed to the action of atmospheric agencies like wind and water, ice, etc., right? So that is resulting in breakdown of these rocks into small pieces or small particles, right? Small particles. This is the one. So these particles are transported by varying distances, right? Varying distances and finally deposited in suitable basins. So thus the formation of sedimentary rocks involve the process that is weathering, erosion, transportation and deposition, right? So now we are going to first one is weathering. Okay. So the rocks exposed to the atmosphere and a hydrosphere. So those are constantly changed by various processes, right? Process of physical disintegration and chemical composition. So the process is that process is known as weathering. So it is caused by precipitation and change in temperature, temperature, frost action, frost action, and plant growth, and animal and human activities, and also dissolution of minerals by chemical action. And physical and chemical characters of rocks are changed during the process of which one? Weathering. Okay? Weathering. So the physical and chemical weathering process are different, but they work together in breaking and disintegrating the rocks and minerals. So this weathering of rocks can take place by physical, chemical, and also biological action, right? So now, physical weathering, that is also called mechanical weathering, right? Mechanical, MECHANICL, mechanical weathering, right? So that weathering involves disintegration of rocks and minerals into smaller pieces through direct contact with atmospheric conditions. What are that? Such as heat, water, ice, and pressure without changing their chemical composition, right? Chemical composition without changing, right? So it causes physical disintegration only, and it is more effective in cold or dry regions. So the physical weathering takes place by a variety of processes such as abrasion, 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 and frost action, and unloading, unloading, and abrasion, abrasion, and frost action, and unloading, unloading, and thermal cycling, and plant and animal activities, right? Activities. At, as mentioned here, this one, right. So now we are going to first one, abrasion. So what is this? So in this weathering means physical weathering, right? So in this weathering, the sediments and other classed, right? So those are reduced in size, right? So and water and wind loaded with these sediments. It have tremendous power of cutting the rocks through which they pass, right? Which they pass by water or ice, something, right? So huge moving glaciers grind rocks in their way and it carry large amount of these minerals. Okay, these minerals. And second one is frost action. So it occurs mainly in the areas where there is a lot of moisture and frequent fluctuations of temperatures above and below freezing point, right? So in the areas that is high altitudes, right? And water percolated in the cracks and joints of the rock freezes during night time, right? So we know that there is a about how much 90%, right? 9% increase in volume of water upon freezing, freezing, right? So the repeated freeze thaw cycle exert pressure on its surrounding, causing fractures in the rock. So as this process that repeats over a time and cracks become larger and break up here, you see here, break up along the joints of the rocks in angular pieces like this. You see here? You see here. So the water seeps into cracks here. Okay. This is the crack and fractures in the rocks. Rock, right? You see a second one. When the water freezes, it expands about how much? 9% in volume, right? And which wedges apart the rock. So now you see third one is with repeated freezing. So repeated freezing, the rock breaks into pieces. Okay. So this is the frost action in the rock. Okay. And next one is pressure release or unloading. This one, unloading or pressure release. So this is the intrusive igneous rock. For example, this is the granite, right? I'll have you know about the granite. So this granite is formed at great depth, right? So they bear tremendous pressure. So as the material is removed from above due to erosion or any other region, reason and pressure on the rock that is released and the outer rock surface expanded, right? So the expansion of the rocks sets up stress, it causing outer surface to break into sheets parallel to the this rock surface, same like this you see here. Okay. So this type of weathering is known as exfoliation. Okay, exfoliation or sheeting. Okay, exfoliation or sheeting. So this is the exfoliation in granite. And also we have thermal cycling, right? Thermal cycling. So this is the in the area of arid regions. So there are large temperature variations between day and night. Okay, between day and night. So days are not, whereas nights are cold, causing different expansion and contraction of some minerals in the rocks, right? So this sharp temperature changes set up different stresses, causing fracture and enlargement of joints in the rocks, and thus breaking of blocks takes place, right? And a plant and animal activities also, that is growing roots in that plant of plants that is present in the rocks, right? So maximum all of you observe some of the places in some rocks, some of the trees are growing like this, right? So that growing roots, plants present in the rocks, it can exert pressure causing a widening of the cracks, right? So that is the burrowing activity of animals also break down rock, producing disintegrated particles, right? So this is the plant and animal activities. So now we are going to physical is over. Second one is chemical. So up to here, physical weathering. Next one is chemical weathering. Okay. So chemical weathering involves a direct effect of atmospheric chemicals or biologically produced chemicals in the breakdown of rocks and minerals by alteration of decomposition, right? Decomposition. So the chemical reactions take place between minerals and water or air interface, right? So it changes chemical composition of the rock, right? So the chemical weathering alters unstable minerals to more stable mineral substances. So as a result, now new or secondary minerals are formed automatically. So from the original materials are original minerals, right? So the main agent responsible for the chemical weathering are water and weak acids like carbonic acid, right? So the carbonic acid is produced by which one? Reaction of carbon dioxide, CO2 gas, right? Carbon dioxide gas with the water in the atmosphere. Atmosphere. Okay? So the chemical weathering is a gradual and continuous process. So it is common in areas of hot, humid climate. So the chemical reactions include carbonation, 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 and oxidation, and hydrolysis, hydrolysis, right? So now first one, we are going to first one, carbonation. What is the carbonation? So the carbonation is very common solution in this weathering process, right? So in this process, the carbonic acid reacts mostly with the mineral calcite, right? Mineral calcite present in the limestone, right? Limestone and chalk. So the formation of caves, right? Balloon caves, some of the caves, right? How to form that caves? The formation of those caves in limestone country takes place by etching of carbonic acid, right? So the carbonate minerals are completely dissolved by acidic, right? Acidic water giving rise to formation of caves, right? And Godavari, Gupta Godavari caves, right? So those are in limestones near Chitrakoot. So that is in the Madhya Pradesh, right? So that is the good example in this carbonic acid caves, right? So this is the reaction. So that is, you see here, water plus carbon dioxide. So it gives rise to carbonic acid, right? And calcium carbonate, that is limestone, and H2CO3, it gives, right, CaHCO3, and bicarbonate soluble, right? And also this one calcite plus carbonic acid. It gives us calcium ion plus carbonate ion, right? And next one is oxidation. Oxidation. So oxidation, this reaction of substance with oxygen is known as oxidation, right? So when chemically active oxygen from atmosphere reacts with iron, okay? This iron, it forms iron oxide, okay? Iron oxides, and it gives which one? Reddish brown coloration, right? So on the surface of the affected rocks. So the oxidized rock becomes weak and crumbles easily, right? So now you see here iron plus oxygen is called hematite, iron oxide, right? This one, Fe2, 2Fe2O3, right? And also hydrolysis, right? Hydrolysis also that chemical that in that chemical breakdown of substance when combined with water, right? When combined with water is known as hydrolysis, right? So it is a chemical weathering process affecting silicates, right? Silicates and carbonate minerals. So the common example of this hydrolysis is the alteration of feldspar minerals into this clay in granite rock, right? Granite rock. And now alteration of feldspar. So that is the feldspars are that the most common mineral occurring in the earth crust, right? So in the presence of this acidic rainwater, um, and feldspars easily break down and form clay minerals, right? Clay minerals. And sodium, potassium, and calcium ions. So those are released into water along with silicon dioxide in solution and carried. That is, you see here, NaAlSi3O8. This is plagioclase feldspars mixed with carbonic acid. It gives rise to kaolinite and sodium ion and silicic acid, right? And also you see here orthoclase. This is the plagioclase. And this one orthoclase. So orthoclase plus carbonic acid mixing with this, it gives rise kaolinite and potassium ion. This one sodium ion. This one potassium ion and silicic acid. Right? So similarly, the chemical alteration of hornblende, augite, and biotite, it leads to the formation of clay, right? Clay and chloritic minerals, right? Now you see here some of the weathering rocks and their products. You see here, so granite rock, right? So in that primary minerals are feldspar, mica, quartz, iron, magnesium minerals, and also hematite and goethite. So these are the primary minerals. And weathering products are clay minerals and quartz minerals also, right? So this is the table that weathering rocks and basalts and limestone, right? Right? So in this clay minerals, right? You see here that clay minerals and this quartz and oxide minerals. So these are the most common residual products of chemical weathering. Remember that, right? So therefore, quartz and clay. So these minerals are the most abundant contributors to clastic sedimentary rocks. Okay. So this is the chemical weathering. And next we are going to the third one, biological. Biological weathering. Okay. So don't worry, I didn't write proper with using mouse. Okay. Biological weathering. So weathering takes place by various activities of living organisms, right? So it includes, what is that? Digging activities by animals causing movement. So it's called, what is that? Animal causing movement means pedoturbation. It's called pedoturbation. P-E-R-O, sorry, P-E-D-O, pedo turbation, Turbation, pedoturbation. Okay, and mixing of materials and action of moss and lichens on various minerals and the rocks. So these are several rodents and insects and the other animals that can burrow into a crack in the rock or mineral, right? So, and constant burrowing widens cracks and breaks rocks apart, right? So, apart from burrowing rocks, it can also be fractured, right? Now, fractured by which one? Pressure, right? So, pressure from growing roots also, right? These roots. So, it known as root wedging. It known as root wedging. So the organisms influence the moisture content of soils and enhance weathering. So in human regions, the growth of algae and bacteria and lichens and mosses on the rock surface are produce weak acids which weaken rocks and it can alter some minerals to clay, right? So now next one is weathering is over. So physical, chemical, and biological. So three types of weathering. So now we are going to second one is erosion, right? Erosion or eroding. So erosion means, so this is the process by which the rocks are disintegrated and removed, right? Removed simultaneously by any natural agencies like flowing of water or wind and glaciers also, right? Glaciers. So the hydraulic action of streams quarry and pluck fragments and pieces of rock and sediment particles from beds of solid rock. So the winds erodes and carries away that loose sand, silt, and clay, that size particles to short or long distances, depending upon its velocity, right? So similarly, the glaciers remove rock fragments and sediment particles to lower slope. Okay, so this is the erosion. Now, next one is third one is transportation, right? Transportation. So sediments transport, right? Transportation means all of you know about that. So transport means going any place, right? So from one place to another. So that is that sediment transport occurs in natural system, right? In natural system where the particles are clastic rocks. So that is, what is that? Sand, gravel, boulders, mud or clay. So these are the some of the plastic rocks. So the transportation refers to the movement of solid particles, right? So you see here some of the particles here. So these are the going with by wind or water or any, okay? So the transporting agents can be running water, wind, and glacier ice, right? So the majority of sediments are usually transported by which one? Main thing is water, okay? This water, okay? Water, it means rivers or streams, right? And also wind also. Wind and they are carried the lighter and the smaller sized particles or materials more easily than the heavier, right? Heavier and the bigger size ones, right? So the force of gravity acts to move these particles along the sloping surface on which they are resting. Okay. So this is the transportation. So in this, the types of sediment transportation are loading. That is the streams, right? The streams transport materials in four different ways. So like, right. First one is dissolve, right? Dissolve load. Okay. So it means materials carried into that solution as dissolved load is part of the moving water. Moving water. So the amount of material in solution depends on the supply of solute and water temperature and the saturation point of the solvent. So some of the tropical rivers carry larger amount of dissolved loads. So then those in temperature regions, right? So that is dissolved load. And second one is suspended load, suspended load. So some of the heterogeneous material that moves through the channel of river, main river, okay? Channel of river, right? So in the water column is suspended sediment load. So mainly silt and fine sand that remain in suspension by the upward flux of turbulent water generated in the riverbed, right? So for suspended load of the sediment to that is to be sustained. So the upward currents must equal or exceed the sediments for velocity, right? Velocity. So this is the suspended load. And next one is saltation load. Third one is saltation load. So it means generally sand size, right? Sand size particles. It means smaller size, this like this, right? So this size particles that bounce along the stream bed, right? Stream bed are moved directly or indirectly by the impact of bouncing particles come under saltation load, right? So the velocity of a particle during saltation is less than that of water in motion, right? This is the saltation load. And next one is, fourth one is bed load. Bed load or traction load. So this one, it includes larger plastic particles, not like this size, larger, okay? Larger particles, plastic rocks or plastic particles. So that are rolled, right? Rolled or bounced and slide along bottom upstream these beds, right? So its movement through the stream is fully supported by the channel bed, right? So that gravel and coarse sand, those are kept in rolling and sliding motion by the this shear stress, right? And now you see here the distance of sediment transportation. The sediments, it can be transported few meters or even less to several hundred kilometers from the source of the origin, right? So it can depends upon the energy conditions of the transporting medium, size of the sediment and slope of the ground, right? So the size of particles decreases with increased distance of transport. So as the coarser sediments are left behind the transportation process, they are usually found, which one, closer to the source area, and fine grained sediments being lighter transported to longer distances, right? And hence found further away from the source, right? So the presence of angular clast indicate short distance of transport from the source, whereas rounded clast show that long transport distance. And mature sediments are deposited further or far from their source racks than immature sediments, right? Now you see here, this is the traction, okay? And saltation and suspension and solution, okay? So this is the mode of sediment, how to transport these rocks, right? Now, last one is deposition, right? Deposition, okay? This is the fourth one in this process, right? Sedimentary process. So now deposition of sediments takes place when when energy necessary to transport particles, right? Transport particles is no longer available. So if the velocity of the transporting medium it becomes too low, the deposition will take place. Right? So the sediments fall down due to the gentle settling of mineral grains and deposited in a basin as layers, with the oldest layer at the bottom and the younger layers lying on over the older layers, right? So automatically, so you see here, this is the some of the rocks here. So So this is called older layer, right? Or older rocks. And in upper stage, that is the younger, right? Younger rocks. So in some layers or beds may be plain horizontal or others may be cross-bedded or graded bedded, right? So the resulting deposits thus reflects the energy conditions of the depositional environment. So this deposition can also be result of a chemical precipitation and evaporation due to what is that? Changing conditions, right? Changing conditions in the basin of deposition. So therefore, the type of a sedimentary rock depends not only on the sediment supply, but it can also on the depositional environment of the basin in which it is formed, right? Now you see here, this is the weathering and erosion. So weathering and erosion are here, and you see here, land transport and deposition by which one? Water, right? Water and wind also. Okay, wind and also some of the ice, right? And second one is transportation and deposition. Now you see from here to here, the transport here. Okay, it's called deposition, right? So now this class is over. So this is um, now that the single quartz grain in the sand or sandstone, it has a story to tell. Now and originally, this quartz grain maximum in your rocks, quartz and mica is necessary. There, that is parental rocks, right? So I will stop here, and I have next class. Okay. Any doubts? Uh, So only one candidate is joined.
Madam, can you share the PPT, ma'am?
Yeah, sure. Okay.
Thank you.